So, this is the lecture series on digital image processing, and today our topic is image compression. Okay, so what is image compression? Image compression is the art and science of reducing amount of data required to represent an image. So, you can consider this as a technique to reduce the amount of data that will be needed to represent an image. Just for an example, say data required for 2 hour standard definition, that is SD television movie using 720 480 24. Okay, 720 cross 480 cross 24 bits per pixel arrays. What will be the value? So as a whole, you will need 224 gigabyte. Okay, so gigabytes means gigabyte. So that is a very means very big amount of space that will be needed. So our main aim will be to reduce the space required to store an image. So to save storage space and reduce transmission time, we'll try to perform some image compression techniques. Say if you have 8 megapixel camera, then what is the size of an one uncompressed image? Just asking you that say you have now with your smartphone which has 8 megapixel of camera. So what is the approximate size of an uncompressed image? Can you tell me? Okay, just imagine and tell me through comment. So if I talk about the applications of image compression, then it is very much practical. Okay, we use it everywhere. Applications in many areas like televideo conferencing, remote sensing, document and medical imaging, okay, fax, that is specimen transmission. So everywhere actually we are using what? Image compression. Some fundamentals you have to know before going to techniques. That is, data compression refers to the process of reducing the amount of data required to represent a given quantity of information. And you guys know that image is nothing but kind of data. So data and information are not the same thing. Do remember that data and information are not the same thing. And you know that in my DBMS lectures, I always start with this thing, that is data, information, knowledge. Okay, I try to differentiate them through some examples, and I hope you have already attended that lecture of mine. Okay, so do note down that data and information are not the same thing. Data are the means by which information is conveyed. Okay, and various amounts of data can be used to represent the same amount of image. Okay, information, sorry. So that's the difference between data and information. Now data may contain, you have some irrelevant information or some repeated information, and that is known as what? Redundant data. Means if irrelevant or repeated information is there in the data, then we'll call that data as what? Redundant data. Now, relative data redundancy, say capital R, then R is equal to 1 minus 1 by C, where C is commonly called as the compression ratio. Do remember that C is our compression ratio, and it is defined as C is equal to B by B dash, where B and B dash denote the number of bits in two representations of the same information. Okay, so that is our compression ratio. If say C is equal to 10, for instance, this means larger representation has 10 bits of data for every 1 bit of data in the smaller representation. Do mind it that if C is equal to 10, this means what? Larger representation has 10 bits of data for every 1 bit of data in the smaller representation. So corresponding relative data redundancy of the largest representation is what? 0 0.9, indicating 90% of data is redundant, and that we have got it from this one. R is equal to 1 minus 1 by C. This formula is very important. I'm repeating again. R is the relative data redundancy and C is the compression ratio, and we define C as B by B dash, and here B and B dash denote the number of bits in two representation of the same information. Is, for example, we have taken C is equal to 10. This means 10 bits for the larger representation for every 1 bit of the small large data representation, and we have got that data redundancy of the larger relative data redundancy of the larger representation is what? 0.9. It means 90% of its data is redundant. Clear? Principal types of data redundancy. What are the different types of data redundancy we will have? So they are coding redundancy, spatial and temporal redundancy, and irrelevant data information. Okay, so three principal types: coding redundancy, spatial and temporal redundancy, and irrelevant information. Okay, so what is coding redundancy? Coding redundancy means a code is a system of symbols, letters or numbers or bits used to represent a body of information or set of events. You know that. And each piece of information or event is assigned a sequence of code symbols called code word. Okay. And number of symbols in each code word is what? It's length. Do note that. Okay. So that is our coding redundancy related information. Okay, then we have spatial and temporal redundancy. Pixels of most 2D intensity arrays are correlated spatially, and you know spatially that is each pixel is similar to or dependent on the neighboring pixels. Okay, we have faced this term spatial many times, and I have defined it in previous lectures also. Information is so unnecessarily replicated. Okay, replicated means what? It is means unnecessarily duplicated, you can say, in the representation of the correlated pixel. So that is our what? Spatial redundancy. So in a video sequence, you will see that temporally correlated pixels also duplicate information. Then last one is our irrelevant information, and most 2D intensity arrays contain information that is ignored by human visual system or extraneous to the intended use of image. So it is redundant in the sense that it is not used. That is our irrelevant information. So you have seen there are three different types of our redundancies. They are coding redundancy, spatial and temporal redundancy, and irrelevant information. So that's all for this class. So today's questions for this lecture is that what do you understand by relative data redundancy? Okay, and what is the formula for calculating it, and how the compression ratio plays a vital role on defining this what our code data relative data redundancy. So that's the question. You got it? What is relative data redundancy and how the compression ratio plays a vital role in finding it. So that's all for this lecture. So meet you in the next lecture. Till then, take care. Bye bye.